Both batteries claim the same capacity, both are fully charged. So why does one fail almost instantly? The answer is tiny number most people never check. And the device won't work lie in this case. Today, we'll wait to find out what's really causing this problem. I'll be running a series of tests, so stick around to discover what that tiny number really means. Let's check the voltage to make sure the battery is fully charged. That's okay. This is the device we use to measure the capacity of batteries, and it has some functions. Okay, I'm going to set cut off at 3 volts. Let's start with the first cell, EVE 26V. Okay, let's start by discharging these cells at a 1 amp load. At a 1 amp discharge, the voltage drops steadily. Very stable. What happens when we increase the load to 5 amps? Let's go to 5 amps. The voltage drops a bit more, but it remains stable. Yeah, that's good. Now for the exciting part, let's rack it up to 10 amps. What do you think will happen? Wow, look at that voltage. It drops incredibly fast in just a few seconds. You see that? The discharge capacity keeps increasing, but something doesn't seem right. Let's wait and see. Wow, look at these results. That's really strange. So, what's going on? Is there something wrong with this cell? We got only 800 milliamp hours? Let's move on to the next one. Discharge current at 1 amp. Just like the previous cell, the voltage stays very stable and drops gradually. Let's increase the load to 5 amps and see what happens. Do you see the difference? Unlike the previous cell, the voltage doesn't drop suddenly. It stays nice and stable. Now, let's take it a step further and push it to 10 amps. The voltage drops quickly, but keep watching. There's more to come. See how stable the voltage is? Meanwhile, the capacity reading keeps increasing steadily. Now, let's compare the results with the previous cell. Wait, something is not right? This is the rated capacity specified by the manufacturer. So, why is the capacity so low? But here's the interesting part. Let's check its internal resistance and see what it reveals. Now let's measure the internal resistance of each cell, and I'll explain what internal resistance actually is. The first one, Sony VTC's 5D. EVE 26B. And the last one, Samsung 29E. You see the difference? So, what is the internal resistance? Imagine the battery is like a water tank. Think of the internal resistance as a valve that controls the flow of water. The higher the internal resistance, the more the valve restricts the flow of water. The lower the internal resistance, the more open the valve is. That's why high internal resistance makes it harder to deliver energy, causing power loss and heat buildup. Huh? Wait, what is this Samsung cells doing here? Now let's verify that with this Samsung 29E. Let's run it at a 10 amp load. Here we go. Now look at that, it's exactly the same as the 26V cells we just tested. The voltage drops in just a few seconds. Bruh. From these tests, you've learned one of the reasons why a battery pack can stop working under load or stop working instantly, like this. And the battery pack becomes almost unusable under heavy load. Because of voltage drop. So, how do you choose the right battery cell for your need? Batteries for lighting devices? High drain and low drain battery. Power bank? I explained that in detail in this video right here to help you choose the right cells. I also show you how to safely rebuild a Makita battery pack in this video. How to build a backup battery for networking equipment. How to restore a Faulty Dewalt battery pack. And there are plenty more helpful videos on my channel. If you enjoyed this one, be sure to subscribe and stay tuned for future videos. Bye bye, have a nice day.